Ian Lane is also a professor at our Silicon Valley campus. He'll be talking about his company, Capio, smart automatic speech recognition. Ian.
Thank you. Okay, so I'm going to talk about something a little bit different. And what we're doing at Capio is bringing really the next generation of human-computer interaction to the world and focusing on human-like interaction. So it's interesting to see today where we are and what people are doing. We've got some unique technology at CMU that we've built over the last 5 years, about 50 man-years of research, 15 patents, and a lot of core technology that actually takes us to the next stage where we can build context-aware understanding systems and systems that just learn from data. So rather than hiring a big team of engineers, today it comes down to data. The more data we push to these machines, the better they become and the better that they become over time. So if we look where speech interaction is today, there's been a big shift just recently, and we see this continue to grow, of people using voice to interact with devices. Here's an example really with voice search, and we're 2016 today, but as we see with search engines, it's gone from very text-based input, and as mobile becomes more prevalent, people are using voice every day to perform speech recognition and perform voice search type of capabilities. You see what's out there with Google, you see what is out there with Alexa. People are now, it's becoming natural to interact with devices via speech. And so this is becoming more prevalent every year. I was just at a conference in Washington, DC, and people have been doing evaluations, talking to real consumers, and finding out how they interact with systems and what they wish it did better. So one of the interesting things was, okay, how many, and this was around, I think, 2,000 people that they interviewed, do you think the voice search commands are fine as it is today? And 15% of people said, yes, I'm happy with it as it is today. The other 85% said, no, I can't answer that. The second sort of area comes into understanding words that I'm saying, letting me speak more naturally, getting the results that I asked for, and this is really not quite there today. It doesn't work as well as you want. And really, the first stage of this is if you don't accurately understand someone, you can't respond to them correctly. And this is where we believe Capio plays a role. So we've been working with a number of companies, and I want to show this video first because I've had a very similar experience in cars today.
USB, please say a command.
Play Lady Gaga.
Indexing, please wait. Indexing, please wait. USB, please say a command.
Play album Octune Baby.
Creating speech commands, please wait. Tracks are not available for this device.
Play album U2.
Say one after the tone for play.
Yeah, and I've just shown the video because I think people have had very similar experiences. I hired a car at SFO when I first arrived here, clicked on the speech button and said, I want to go to downtown Mountain View. And it had to come back and respond again and again. And by the third time, you're driving down the highway down 101 and it says, oh, you seem to be having trouble using Ford Sync. Please go to www.sync.com to learn how to use me. And it's just not usable as it currently exists. So at Capio, what we're looking to build is sort of mimicking human-like interaction. And we've already developed a few prototype systems with a number of companies, but here's sort of a vision video of what we're doing today.
Did you make sure to bring the invitation, Daniel?
Yep, got it right here. How are we doing on time?
A little early. Is there anything you need along the way?
Actually, yes. Let's get coffee. Hey, what's happening over there?
Conversations are uniquely human. When someone speaks to us, we draw from a lifetime of embedded knowledge to distinguish language from noise. If words aren't enough, we look to gestures, facial expressions, and body language to find context and interpret meaning. learning from every interaction to continually improve the way we communicate, so we can respond appropriately and insightfully in the blink of an eye. At Capio, we're giving the power of human conversation to applications across every industry. With our contextually aware ASR engine, people speak naturally to the technologies around them, and voice-enabled devices react intelligently and authentically like never before.
Looks like Fifth Avenue is being closed for a special event. I'll update our route to avoid traffic and include the nearest coffee shop along the way.
Oh, did you remember to set the alarm?
I can take care of that for you, Sonia.
Thanks, Capio.
No problem. Enjoy your evening.
Okay, so we created that video for the LA Car Show. We were nominated as one of the top 10 innovative startups in automotive, and that's one possible area that we are using this technology today. The real reason where we think now is the right time to do this is we've seen a huge amount of data is becoming available, especially through connected devices, a sort of a step change in machine learning with deep learning technology enabling us to get accuracies and performance that we haven't been able to have before. And then the third is parallel computing. So today, with highly parallel computing architectures, CPU, multi-core CPU and GPU architectures, we're able to handle all of this data in real time, doing understanding, and really apply this in the real world. So really the goal at Capio is to build human-like speech applications that just work, and they need to be able to work quickly so you can interact with them, and really they need to continuously learn through interaction. And we're doing this really based on a core set of technology at CMU again, looking at accuracy, naturalness, so people shouldn't need to learn how to use the system. If you can talk with another human, you should be able to interact with it. Latency is key, so you can have a smooth and interactive dialogue, and then having these systems that evolve over time just by interacting with them. So we've built a suite of technologies around this, looking at context, self-learning, automation, really bringing in data, and then our core competency in GPU and CPU technologies to bring the best accuracy in the world for whatever application we apply this to. One of the first products that we've spun out from this is what we're calling Speech Team as a Service. And really the idea here is if you're shipping a product that has some type of speech interaction, what you really want is a speech team in-house. You want 20, 30 of the best engineers in the world to help you build a speech engine and a natural language understanding engine that's optimized for your specific product. The challenge with this is it's very expensive, and really today you can't. So Google can, Apple can, Amazon, Nuance, Microsoft have teams of that size, but for most other companies you can't. You can get something off the shelf, but you can't hire a team of 20, 30 engineers to specifically optimize for your product. And so what we're building is a platform that really automates the entire speech team. So if you have a product, either you're shipping or you're in the design phase, you have some ideas about how it's going to be used in the field, and with some sample data, then our Speech Team as the Service does the rest of the work. So today we provide the best-in-class accuracy. It's the highest accuracy for any specific product. Given the appropriate data, we can reduce operational costs because you don't need an in-house speech team. You can access this all via an API. And then we're offering something which is very novel in this area of continuous maintenance. So rather than ship and build as it has been in the past, our systems learn, they continually improve every day as more people use them and more people interact with them. So we've done this for a number of customers over the past year and a bit, and really what we compare ourselves as is the best in the world off the shelf for any solution that exists there today. And so with as little as 10 hours of data, we're able to get jumps in accuracy between 10% and 130% in accuracy by optimizing for each specific product. We've passed around 600 million minutes through our engine today, and really what we found is the more data we can push to it, the better the accuracy gets over time. And off the shelf, if you're using a speech service or an NLU service, and it doesn't work well today, Capio can very quickly adapt and build a system for that. So one customer example that we've looked through is they brought us 10 hours of data. This was quite a challenging task. They're using it for data analytics. And off the shelf, with that 10 hours, we could provide them sort of 68, close to 70% in terms of speech recognition accuracy. And as they start pushing more and more data to the service, we just get improvements in accuracy over time. And this is really a shift in this area, in that it's not now the engineering time that limits the quality of the system, it's how much data you push to it. The second area that we've been looking at is contextually aware computing. And so one of the core things for speech understanding is not just what the person is saying, but where they're saying it, what time of the day they're saying it, who is saying it, and maybe what they're doing when they say it. So we've built a contextually aware engine. It's based even on computer vision and contextual understanding, and being able to integrate this tightly within the other analytic components, we can effectively leverage this context to improve speech recognition and improve speech recognition accuracy. So I'm here talking about smart cities, and so I want to sort of think about how this can be used in the smart city environment. So really, one of the intriguing things that is happening is data. So with data, you can have much more appropriate responses. You can have responses based on real-time information, and you can even start leveraging this for immersive interaction in cities. So if I'm in a city, similar to the video that we showed, I should be able to ask information about objects around me. And again, this is based on context, self-learning, and automation of a lot of these engineering processes. So areas that I can see it being very useful for is, one, with real-time data APIs from smart cities, we can start providing much more useful information. And so traffic is quite well handled by a number of APIs today, but parking is not. If I want to get to a restaurant, I don't just want to drive there. I want to find a parking spot before I go to the restaurant, and that wealth of information is needed to help users in the real world. If we want to be able to move ahead from just sort of these interactive systems to immersive interaction, if I'm there, standing in the street, there's restaurants around me, and I want to ask questions about, so is that French restaurant to my right better than the Italian restaurant to the left? To do that, you need to understand where they are, where people are in the real world, and what they could be referring to. And so again, smart city and highly censored city infrastructure will be able to capture that information and appropriately provide it to users and these interactive dialogue systems. The third is sort of a goal of mine of trying to start speech enabling anything. So today, everyone carries around a mobile phone with them. There's a microphone there. There's enough sensors that you can do speech interaction there locally on your device. But as we move into the future, carrying a mobile device with you all of the time may not be as common. But if there's a microphone on any device, you should be able to interact with it, sort of as you do with Alexa today. And looking at smart cities, this could be on any smartly connected device. So asking your cross signal about how do I get to a specific location, parking, rental bicycles, etc. In the future, I think we'll see much more speech-enabled devices, and I think Capio will be helping to turn this into a reality. So I'd just like to wrap up with introducing myself and my team. We're sort of right in the middle of funding at the moment, dealing with term sheets, so I'm continuing on the phone. But we've got myself, we've got Jean-Claude Junta, who was the Vice President of Panasonic, now as part of our team. We've got Product Manager, Jun-Suk Kim, one of our PhD students who got a fellowship under CMU to help spin this out. And another 5 engineers, 4 from CMU, who've helped take this technology from CMU out into the real world. So thank you for your time, and if you have any questions, just please grab me. Thank you. Thank you.